现现在的 YouTube 就是它直接就啪就开始直播，就是好像没有任何缓冲一下的空间。之前就是还要按一下，它才会开始播。对啊。还有人想要加签的吗 ？Anyone who would like to be added manually to the course? Okay. 所以试育，请你举一下手好吗 ？So if you would like to do add and drop, just go to him, look for him. Okay. So he is one of our TAs. Then now I am starting the lecture. So okay. Welcome to our first course. I suppose this is the first course of physics in your university. I would like to do an introduction about what is physics, and I will do an introduction about our rules and our examinations and our gradings. How do we put grades on you? So this is the first course. This course is going to be bilingual, so I will do mainly all of the physics in English, but if it's very, very, very important, or if I just knew the concept is very abstract, very hard to understand, I will explain it again in Chinese. So don't worry, and we'll do it slowly. 这个课我会主要用双语的方式来上，所以主要呢，比方说一些讲故事的部分，然后或者是简单的部分，我会整体用英文说一遍。那有一些很重要的，尤其是一些很抽象的，或是比较不那么动物性直觉的部分，我会用中文再讲一遍，所以不用担心。然后我会一直提醒自己讲慢一点，讲慢一点，讲慢一点，因为我一紧张就会越讲越快。好，那所以我们不用担心，这是语言的部分。那再来是 so this is add and drop, and then I just explained it before the lecture. So if you have that kind of need, and then just go to the back of the lecture room and look for the TA and leave your personal information. And first, I do the introduction to myself. This is my name, Zhong Jiewen, and I am a doctor. I just get my PhD degree in Germany, in the University of Bonn, and my major was experimental particle physics. So if you still have the kind of the impression or memory, a few years ago, and we were looking for the Higgs boson, the particle which explained why everything has mass. I was in that experimental project, and I was in charge of designing a detector for the charged particles from Higgs boson. So I have to analyze the signals from Higgs boson. I have to put the detectors at the right positions to catch all the particles. So that was my work. And after the work, I was working in Switzerland at CERN. That was me. Okay. And after my work, I just came back to Taiwan, and I work in industry. So there is an industry called AU Optronics, Yoda Guangdian, and I was a sort of scientist there. I started to do some research on liquid crystal, the physical properties of liquid crystals, the mechanical properties and optical properties and electrical properties on liquid crystals, and I tried to apply my knowledge in field theory and try to develop some method to manipulate the liquid crystal molecules and let them arrange themselves in a special pattern So that was my work at the industry. And then I was accepted as an assistant professor in the Department of Electrophysics here in this university. And now I am working on symmetry and symmetry breaking. 对称跟对称性是怎么破坏的。So I'm working on the symmetries in matters and symmetries in everything, and I am very interested in if the symmetry is broken, if it's not symmetric anymore, and then what happens. So, and if the symmetry is broken, and then we will have defects, and then we can classify the defects in different groups, and we can use some knowledge in topology to do it. So now I'm working on this. Okay. And then, so this is me, this is my name. And if you would like to find me, please send email to me, make some appointment. And if it's needed, and I know we can have an appointment somewhere. So if you suddenly come to my office, and sometimes I'm not in the office, sometimes I'm in the lab, and sometimes I'm not in the university because I have some business elsewhere. 不是在外面做生意的 business 哦，就是有的时候我会去外面演讲或是什么什么，所以你突然跑过来的话，我可能不会在，所以请你就是先写 email 给我，如果 email 可以回答，我就直接 email 回答，如果说有需要见面的话，我们就在这边见面，然后或者是再跟你约时间。好 ，and my research interest is I just say that I'm very interested in symmetry and symmetry breaking. And basically, it's just the order and disorder of all the matters. And here's my general interest. So I'm very, very interested. I am a nerd in sci-fi, scientific fiction novels. And I'm very interested in sci-fi movies, 科幻电影. And I like fine art very much. And I like psychodynamics. I'm taking some lecture on psychodynamics. So this is really helping me to do good educations to the students. Okay, and then I would like to invite our teaching assistants to do introduction. So we start from Hui Ting, okay? So, and you can just introduce yourself and please come here and you can leave your personal information at the table. 还是 or do you need some time to fill in your names and your emails or your ways to contact? Yeah. Okay. Student who don't speak Chinese and her name, the meaning of her name is a common full of flowers. I find it very poetic, isn't it? When I just got her name, I was like, oh. This is the room number in our building, and that is her office.
Okay. 这样就好。
How about your research interest? You don't have any interest. Could it be? I'm telling you, you're a supervisor.
STM. STM.
What is that? STM? Could you do a little?
STM just scan material surface, and we do some how surface, the roughness of surface, or we can see the material surface by STM, and whole name is scanning tunneling microscope. Yeah. Okay.
If you're interested about STM, then you can just use the cell phone and do some Google, and then you can see what is it. It is kind of microscopy. You can see atoms and you can see molecules, which is very, very fascinating. Okay. So this is the other TA. His name is Shi Yu. Do you have an English name?
No.
No, we don't have English name.
Yes.
Shi Yu. 你有英文名吗？ Alice. Okay, her name is Alice. If you would like to call her English name, and her name is Alice.
用哪一个吧？中文。
中文。按 Control 跟空白键。
空白键。
是语长。
57667。
是意思吗？
对。
好 ，OK。
766767766776。656。
Yes, this is the number of our lab.
Yes.
Why are
Research.
you researching?
Liquid crystal.
Okay.
Yes.
Yeah.
Okay.
Just a small introduction to all students.
Yes, it's my
You can do it
first.
slowly, don't worry.
Oh, okay. It's my first time to, to be a TA. Yes, and now I major in physics. Yes, and if you have any question or problem, you can have a discussion with me. Yes.
Okay.
He is a professional teacher, not like me. I am a part-time teacher. He is a professional teacher. And he graduated from the University of Education, isn't it? 你是不是从师范大学毕业的？
对。
And then you get all the credits for being a professional teacher in the school.
哪一个？
对，你有修教育学分吗？
Yes， 有修完，
有修完。
但没有考试。
Oh, okay. And then he is doing teaching in a supporting school. 在补习班，你是教 what is the information that I'm just going on? I will leave it on our website too. So don't worry if you have any suddenly you need some information, you can always get on our website and get the information. Okay, now we are starting with physics. Physics is just knowledge of nature. And I like the word physics in Chinese very much because you can see everything from two words. So physics is just senses of things, senses of every object. 物理就是物东西的道理。And I think that kind of language doesn't really exist in English. And I think the word physics just originated from Greek. Yeah. In a Western language. But anyway, we are looking for the knowledge of nature. And here is the history, or here is the story of the physics. So actually it started from something called, natural history. And in natural history, if you ever visited the Natural History Museum, then you can see that human beings are doing observation about the things around them. So you can see they observe the animals, they observe the plants, they observe the rocks, the water, the air, the fire, the wind, and they're just doing observations and they try to record everything. But then here are some other people. Observation is not enough for them. They are looking for explanations for the things that they look. So now we come to the philosophy of nature. And the philosophy of nature can be divided in several different groups, and they are interested in different parts of nature. Like some of the parts, they are very interested in the relation between human and nature. And some of them is looking for, is there anything above reality? And some of them is looking for what is the origin of the earth? What is the origin of the universe? And where are we heading to? So here's another kind of topic. And then here are a group of people who is very realistic and they focus on the real things around them. So they are very interested in how nature works. So the word works. And then they start to develop experiments because they have some theory about why things happen that way. And they produce some experiment, they would like to reproduce the results. So experiment and reproducible results. This is a very important condition for natural science. So then we come to natural science. So from all the chains, and you can see that actually natural science is a part of philosophy. And for the natural science, and we divided ourselves in several groups again, like biology, chemistry, mathematics, and physics. And I can say that actually physics is the base for chemistry, and the base for biology, and math and physics. The relation between them is a little bit complex. Sometimes physics triggered mathematics, and sometimes mathematics triggers physics. And usually the physicists have to use mathematics as a tool, as a language to describe what we say, what we are, to tell the story or to describe what we are looking for. And for physics, we are especially interested in things and interactions. So things and interactions. And what about things? And things is matter. So from now on, we are using the word matter. In Chinese, it's 物质, matter. Okay, and then go on. So here, I would like to show you how physics think about matter. So we are generally looking for the fundamental constituents of matter, 就是物质的基本组成, the fundamental little parts of matter. So actually we started from something that we can touch, but we would like to look more into the things, and we would like to divide it into small pieces, and then we keep dividing it, and we try to look for the simplest unit for everything, like particles. So we have a matter, then we get molecules, and if we get into molecules, we get atoms. And then into the atoms, we have electrons, and we have nucleus. And then if you get into the nucleus, you get protons and neutrons. And if it is still not enough for you, and then you can go into the proton and you get quarks. And then we are still going into it. And for Huiting, and her eyes is generally the microscopy, is looking for something around this level. So we can just look at the atoms by the microscope. But when we are getting into the levels like quark, additional question arises. I think in the second semester we will learn something which is called matter wave, 物质波. And if the things are very small and we cannot use the model of particles anymore, you have to describe everything in the form like a wave. And the wave is telling you the possibility for something to exist. And if we get into that kind of situations, and here are some other problems with theory to describe the existence, and then you can see that if you consider mass and the mathematics doesn't work anymore. So in that kind of situation, we start to ask ourselves, so what exactly is mass? And Einstein just said that actually the energy and the mass, they have a kind of relation, like E is equal to mc squared. So what does it mean? So what is mass exactly? And then here are some other theories, and they just explained the origin of mass as a phase transitions, just like water can turn into air, they can turn into vapor, they can turn into liquids, and they can have the form as ice cubes, as crystals. So we are explaining the origin of mass in that kind of picture. So you can see that this is from the beginning to now, and this is our search for the fundamental constituents of matter. And then the second topic is the interaction. Interaction is something and something, they do something together and there's a result. And that is interaction, 就是交互作用. And here's some other thing, changes. So now this is the state. And then maybe, for example, if the air conditioner is broken and everybody get very frustrated, and some of them running out of the classroom, and then the status changes. So we are looking for the definition of changes, and we are looking for a way to describe changes mathematically. And then here we come to the professional topic, which is called energy or force. And actually we start from force, and then we get into a more general idea, which is called energy. 这边比较抽象，我稍微讲一下。刚刚我们先讲了物质嘛，然后再来呢，大家就会关心说物质跟物质之间，它们两个会发生什么事情？有的是两个物质之间，它们就会产生一些交互作用。那有的是那个物质本身自己一个好好的，然后它就会开始变化。它就开始做一些变化，它跑掉了，它飞走了，它爆炸了，它融化了，等等。那这些事情呢，就是所谓的改变。那改变的话呢，我们接下来就会带到的概念就是力是造成改变的原因。然后有一个是那个嘛，还有另外一个是没有办法用力解释的，就是相变，就是固体、液体、气体等等，那个就会牵扯到另外一件事情。那么这也是为什么呢？我们光讲力是不够的，我们还要再引入另外一个更普世的概念，就是能量。Okay, so interaction and changes, then we have to study forces and energies. Here are some examples for the forces. This is gravity, and then I will tell you why here the bowling ball and the feather, they can fall just exactly at the same speed. And here's another kind of force. This is the force in deformations. So this is elasticity, 弹性，就是跟形变相关的力，这个叫弹性力，这个是重力。And then here is the electric force. We cannot see it directly, but you can see that, wow, this is so strange. Why the styrofoam pups stick on my cat? So what's going on? So here's another kind of force. This is the electric force. And then here's another kind of force. We have a magnet, we have a battery, and we have the wire, the shaped wire, which is in a loop. You just stack it in, then you start to rotate. So what's going on? And here's another kind of force. This is the magnetic force. This is from the magnets. And actually the electric force and the magnetic force, and they are just exactly the same kind of forces, but they are working on different objects. Okay, so here are examples for the forces. But for the physicists, we just, it's very hard to say if we discover it or we manipulated the mathematics to make it look like it. Is very hard to say. 所以那对物理学家来讲，这里有一件事情哦，其实因为我自己是学基本粒子出身的嘛，所以那我看到这个的时候，其实我已经有点搞不清楚，到底是自然界就是这样子呢，还是人类强迫性的认为自然是这样子呢？其实对我已经有点搞不清楚了。 但无论如何，如果你用数学公式去形容那个力的强度的话 ，if you use mathematics to describe the strength of your force, and you always find a relation like this. So R, this is the distance between the two objects. Here are force between them, and here is the distance between the two objects, and here are the force between them. And we can see the dependency. This is 1 over R squared, gravity, electric force. And don't you find it a little bit interesting? I wonder, I am sure some of the students, when they are learning physics in senior high school, and they start to wonder, what's happening with this kind of two forces? And there are two different forces working on different objects, but they are showing the same mathematics. Why? And some of the students starting to ask questions like this, and this is a very good question because physicists are looking at it too. And here are 4 fundamental forces. We can see gravity and electromagnetic forces is everywhere. And here is the weak nuclear force if there are some nuclear interactions. And here is the forces inside between the quarks. So here is for smaller particles. And the 4 kind of forces, they are having exactly the same form. And this is the energy. We will do an introduction about the energy, but please just take it as it is right now. And you can see the 4 forces, they are taking exactly the same form, but they have different strengths and different ranges. Okay, so all the theorists in fundamental physics, fundamental particle physics, they are taking their whole life to look for a general mathematical representation for all of these things, and finally they can sort of have a standard model. So this is called standard model, 标准模型. So they can describe every kind of forces just in the same model, but with different strength and different range. And this is actually the basis of the grand unification of theory, the GUT, 就是统一理论、大一统理论吗？还是大统一理论？就是爱因斯坦的梦想。Okay, fundamental forces. And here's another example for how physicists think. So here's the character number 1. We are looking for a general explanation for everything. So we can see the particle model. We just try to simplify everything into particles. And things are the combination of particles. And for the forces, you can see we use the same mathematical model, and we try to put it on everything, just try to use the same model for everything. So we are looking for a general explanation for everything. So this is how physicists think. And here's the example. We will learn it in the first semester. You can see that if you are describing a swinging spring, if you are describing a circling particle, if you are describing a pendulum, and then in the second semester, if you are describing a string wave and electromagnetic waves, and all of them fit into the simple harmonic oscillation model, the cosine omega t functions. So this is the frequency, this is the time, and this is how the physical parameters changes in all of these things. So we are always looking for the general explanation for everything that we see. And then you can see we never stop asking why. We would like to know, why? Why it goes that way? What happened? And that kind of asking never stops. And then we are always looking for a deeper or a more general causes for the thing. So this is character of physics number 2. We never stop asking why. And these 2 important characters is just giving a very important property of physics. This is the foundation for all the science. So actually physics is the basic element for all the knowledges. For example, like the electromagnetic interaction between the charged particles can be applied into chemistry to describe the combination for atoms into molecules. So, and then for the fundamental forces, the phase transitions can be applied into biology to explain the growth and the forms of biological tissues. So we are, if you have a good knowledge in physics, and basically can handle almost everything instead of the things in your inner heart. Okay, so. And here are some important topics in physics that we pay attention to. We like to study motions, 运动, light, 就是光, heat, 就是热, electricity and magnets, 电力跟磁力, existence of matters, 物质如何存在，为何存在, time and space, 时间跟空间. 所以这是6个大主题。物理学最关心这6件事情。So physicists care about these 6 topics. And all of these 6 topics in the modern world, we can go on with the atoms and molecules, nucleus, particles, fields, solid, fluid and soft matter, stars and galaxies in the universe. And here are the advanced physics. So we study these 6 topics in the university, and then maybe you go on with those other things when you are when you are in the master course. And this is the professional names of them: mechanics, 力学, optics, 光学, thermal and statistical physics, 热力学或者是统计物理, electromagnetism, 电磁学, 然后 quantum mechanics, 量子力学, relativity, 相对论，所以这个就是他们各自连接到这6种重要的问题。然后下面有一些别的专用名词，有兴趣的同学可以看一下。好，需要中文翻译的这里也有。Okay, and here is the core theory of physics. The 4 important foundational theories in physics. So this is mechanics, and we have thermophysics, statistical physics, we have electromagnetism and quantum mechanics. And we divide them into 4 different groups because they are using 4 different mindsets. Sometimes those mindsets doesn't communicate with each other. And for optics, it's actually a part of electromagnetism, so I didn't really, I just put it into the group of electromagnetism. 我们会把这4大力学我们会把它分开，是因为这4种力学呢，他们的思维很不一样，甚至很多时候是没有办法翻译跟沟通的。那么很有趣的就是，你学了这4大力学之后呢，你就会比较，你对于物理学，就是这4种主要的模型，对你才会有比较深入的认识。那光学的话呢，我会觉得它算是电磁学的一个分支啦，所以我这边就比较没有特别说出来。但是因为光学它是一个非常好用的工具，所以通常我们会在物理系里面光学会独立出来，光电系、电机系也是，就光学会再独立出来。Okay. And mechanics, electromagnetism, and thermal and statistical physics, we usually will put them into the group of classical physics. So this is from Newton, from Lagrange, some old physicists, and here are someone like Planck, like Boltzmann, So in these 3 different topics, and then you can use the concept of continuity to solve basically everything. But for modern physics, which is started from quantum mechanics, you have to use a completely different mindset. You have to divide the energy into packets. So quantum mechanics and relativity, this is very modern too. So for modern physics, and then we start to touch these 2 topics. And here are the other things, here are the advanced things. So now you can learn the words like classical physics and modern physics, or 古典物理跟近代物理。Okay. And in classical physics, we start from moving particles. Then we work on rigid bodies. Then we work on elastic bodies. 这是指点，钢体，弹性体。And then we have the big theory. F is equal to ma. This is momentum is equal to mv. V is velocity. In rotations, we have to work on torque. We work on the inertia, 惯性 in rotation. Then we introduce waves and heat. This is what we are learning the first semester. And in the second semester for the modern physics, we have to use all of these objective models to describe the subjective things that we are not able to see. Like the moving charges, we cannot see it, but somehow you can measure it. And like fixed particles, free particles, oscillating particles, and here are something about relativity. And we are using the concept in orbital motions, and then we try to describe the behavior of electrons around atoms. So learning classical physics is very, very important because you can have models in your mind and then you can use it in the modern physics things. So that's why we never directly jump into modern physics, and the barriers too high for you. 所以我们在第一个学期，我们在古典物理的地方，我们会告诉大家很多基本的模型。好，那我们在第二个学期近代物理的时候，我们会把这些模型用来形容你看不到、摸不到、无法感觉到的东西。对，那所以第一个学期的基础非常的重要。比方说，我们学了轨道型的运动、旋转的运动之后呢，接下来我们会用那个模型去形容在原子里面电子是怎么绕着原子转的。虽然最后等到薛定谔提出波的方程式之后，大家都知道说其实电子并没有这样子转，它并不是这样子转的。可是波尔他在什么都不知道的时候，他决定使用那个模型跨出第一步。那我会觉得使用这个模型跨出第一步这个动作是很重要的。他之所以大家会觉得这人很厉害，是因为他可以做这件事情。那我们从第一学期，然后到第二学期的时候，我会教大家要怎么样做这件事情。好 ，OK， so classical physics and modern physics and how they are related to each other. And here we focus on classical physics in this semester. Yeah. Okay, so we take a break here for 10 minutes, and then please come back. Then I'm going on with the rules. 所以我们在这边先休息10分钟，然后回来我会再跟大家说我们上课跟考试的规则。